Kylie, can you hit the lights behind you, please? Thank you. All right, so I want you to have out your parent functions graphic organizer because it's going to help you. Can I borrow this real quick? Not graphic organizer, but this sheet that we printed out the other day so that you could have an example of all the different parent functions. So I want you to take a couple of notes because this will help you, especially long-term in studying. You never got one? Oh, I have a couple extra.
What about the book?
We need that tomorrow. Did you not read that?
Oh, alright.
We will use it starting tomorrow, basically through spring break.
Spring break, man, weekend.
Next week is the week before spring break.
No, alright. Oh, I never still room.
I thought they did give out progress reports at some point.
No.
Oh, need to.
Oh no, I think they're saying that you, since you can see everything online, to just look there. Does anyone else? No, you literally have access online. Why would we print out something that you're gonna throw in the trash or throw in your backpack and never look at again when you can look online? Like, think through that.
Alright, I guess we don't need any report cards there either.
I mean, you still get the grade. Does anyone besides Caitlin need this parent functions sheet printed out? Going once. Going twice.
No, sir.
It is just her then. Alright, slide 6. Print. Nobody else ask me for one later.
Wait, what?
You got one.
Do you have the parent function sheet already?
I do.
Then you're good. Alright, so I'm going to get that off the board. Let's look at our responses. I want to talk about these answers. So here was a graph given to you, and I want to point this out. When you see a graph, should it be pretty easy to identify what the type of function is? Yeah. The shape is unique to each type of function. What shape is this?
A cubic.
That's a cubic function. So hopefully, yes, we all got there except for one. Please remember absolute value. What does the absolute value function look
It's
like?
like a V.
It looks like a V, okay? Absolute value looks like a V. And we're going to go into more detail about some of these things today. But the absolute value function looks like a V. So that's how we recognize each of these.
I recognize because it's value. It's got a V in value.
It does.
So.
Now, the next one. Was the next one a little bit harder to recognize?
No.
Okay, so Anthony was good. Anna, were you able to easily see this one in the table? No? Omar?
Somewhat.
Somewhat, okay. Does anyone have an idea of some easy ways to identify what the function is in the table? Say that one more time. Hey guys, if you recognize the shape really easily in a graph, could you have graphed these points? Yes. And I bring this up because I want you to understand the identifying the parent functions does not have to be hard. An easy step, if you have a table, is to graph it. Please make that note on your parent function sheet somewhere that if you have a table, you can easily graph it.
So how you graph it on the calculator?
You graph it by hand. You can graph to ID parent function easily. There is a way to do it on the calculator. It's actually harder on the calculator than doing it by hand. That's the reason why I say that. You can graph to ID parent function when given a table. And so I'm really glad you said that, Ishmael, because that is a great point. That's a super easy way. Now, before I do graph this one, I want to look at something else. The graph is an easy way to tell the type of function. However, what defines every type of function?
The rate of change.
Thank you. You can also look at the rate of change. And I do want to look at this rate of change because this is going to impact us moving forward. So maybe flip over your parent function sheet, write down this table, and let's look at this function's rate of change. Because this is one of the harder tables to identify the rate of change or identify the function, but it's actually building on something we've already done before. Do you have this sheet already? Okay. So, we always want to remember, should we only look at the change in y? Or how y is changing?
No.
No, thank you. So, how's the x changing? That should be pretty straightforward.
It ain't changed.
Negative product.
Y'all, look at those x values. What mathematical operation is happening within those x's?
Plus one.
Thank you. It's adding 1, right?
Oh, yeah.
It is going from negative to positive, but we want to notice that the rate of change is plus 1 to the x. Okay, so that's not going to impact me a lot. Anybody know what's happening to go from negative 8 to negative 1?
Plus 7.
Okay, so plus 7. Negative 1 to 0. Plus 1. 0 to 1.
Plus 1.
And plus 7. Okay, I don't have a constant additive rate of change, so let's look a little bit further. To go from plus 7 to plus 1, what's happening?
Add addition.
Adding a negative or subtracting. Subtracting how much?
7. 6.
To go from 7 to 1?
Oh, 6.
It's minus 6, right?
Yeah.
What about 1 to 1? 0. So plus 0, and then 1 to 7? Plus 6. I heard Anthony say quadratic. Based on what I'm seeing right now, is this quadratic?
Yeah.
Remember, for it to be quadratic, once we did 2 sets of differences, this was what?
Oh, this is the second line.
Well, the first one was supposed to be a linear additive rate of change,
Yeah.
but the second one was supposed to be
A quadratic.
constant additive. Remember, for this to be linear additive, this had to be constant additive.
Okay.
Okay? Is this constant additive right now?
No.
So is this quadratic?
No.
No.
It can't be square root either.
Okay? So what about to go from negative 6 to 0? Plus 6. What about 0 to 6?
Let's see.
Oh, that is constant additive.
But then Mr. Kenny, that's the third one, so that really
I
don't
think
matter.
absolutely.
Hold on. You're thinking cubic? Let's look at it. If this is linear additive, and you should have this written down by now. And I applaud group 4 for already getting there, right? We should already have this table written down. We should have these rates of change already written down. Somewhere. You have plenty of space on that sheet.
So it's plus 6 to get all of them.
Well, notice it's constant additive here, which makes this set before it what?
Disappear.
No. What type of function had a constant additive rate of change?
A linear.
A linear. So if this is constant additive, this is,
A linear rate of change.
remember, this is not the rate of change for the function, so we're just going to say it is linear additive. Right? It's adding at a linear rate. But I don't want you to say rate of change, because the rate of change is what the rate of change is for the function. Right? And I haven't gotten to the rate of change for the function. But what type of function had a linear additive rate of change? So remember, exponent, what is an exponent? Repeated what? Multiplication, right? So remember, go back to what those operations are. An exponent is repeated multiplication, so exponential has that constant multiplicative rate of change, right? What type of function had a linear additive rate of change?
Square root.
Not a square root,
I mean not square root,
not a
cubic.
cubic.
What's the other? What's the other one?
Quadratic. So I'm going to pause there for a second. I want you to notice the rate of change is quadratic. Remember, the linear was x to the first, right? Anytime you have a linear, it's just x, which is understood to be x to the first, right? Quadratic is x to the,
Second?
thank you, second.
Exponential is to the third.
No, it's not.
I mean cube is to the third.
Thank you. Exponential, remember, has what as the variable?
It's
Or
an
has
x.
what as the exponent?
X.
An x or a variable, right? So this is a quadratic additive, what?
Rate of change.
Rate of change. Notice the rate of change, remember, is always that first set. And so you keep going until you get to constant additive. Because I know this is constant additive, I know it's before it was linear additive, and y'all better remember this because we've been over it way too many times. What had a linear additive rate of change?
Quadratic.
So it's a quadratic additive rate of change.
So what's the parent function?
So, well, what type of function then would have a quadratic additive rate of change? No, it's a quadratic additive rate of change. Y'all already has told me. It's what? Cubic.
Oh.
See, I ain't even know that.
I put cubic, I just didn't know why I put it.
Okay, well, and there's multiple reasons. We're going to look at another reason in a second. What are your questions before we continue?
Is it an easier way to figure out what the
Yes.
function is without doing all that
Yes.
Can we learn
What
that?
did Ishmael say we could also do?
graph?
We can graph it.
That's it.
How else are you going to identify? Actually, there is one other way. We're going to talk about it in a second. But I do want to emphasize, and I'm going to continue to ask this, and so you need to note this. A cubic function has what type of rate of change? Quadratic. A quadratic function has a linear additive rate of change. And the reason why this should make sense is it's x cubed, and then it's x squared, which is quadratic, and then it's x to the first, which is linear. Right? It's always one power less.
So like a chain.
Yep.
That does make sense.
I know, it's beautiful. Math has this like pattern to it, which is why we said from the very beginning, math is what? Come on, y'all, what is math? The study of patterns and relationships, right? It's not random, right? A cubic function has a quadratic additive rate of change, x squared,
And then the quadratic has a linear.
because it's x to the
first.
first. Technically, what would be one exponent less than, or what would be one power less than x to the first? X to the,
0.
and that's what we would consider a constant function. Because what's anything to the 0?
0.
No, sir.
0.
No. 1. Anything to the 0 power is 1. You can test it on your calculator, which
Wait, no.
Anthony doesn't believe me. But anything raised to the 0 is 1. We'll go into more detail about why.
Wait, why does it 1? If 5 times 0, it should be 0.
But that's 5 times 0, not 5 raised to the 0.
Oh, so why it ain't 5? Because you're not multiplying by nothing.
Well, okay. I'm going to take 2 minutes. Please pay attention. If you have a question, let me know. So I'm going to point this out. Technically, we always say that 5 to the first is just 5, correct?
Yeah.
But we also always say that an exponential, or an exponent is repeated
Addition. Multiplication.
multiplication, right? It's not just 5. Another way to understand it is as 1 times 1 5. 5 to the second then would be 1 times 5 times 5. In a similar way, 5 to the third would be, does anyone know why this 1 is important?
No.
This wasn't negative cube.
Not just that, I believe that was an identity we talked about.
And the multiplicative.
It's multiplicative identity. What's 1 times 5? 5. So the 1 is that multiplicative identity. It's not changing anything. But notice, Anthony, what are we always starting at?
1.
So 5 to the 0 is still 1,
One. Oh.
but how many 5s am I multiplying by?
0.
So I just don't have a 5 there. That's why it's 1.
Okay.
Okay?
See, I never knew that.
Uh-huh. and we'll go into more detail about this later, but that's also why 5 to the negative 1, notice when we have a positive exponent, it's repeated multiplication, so when it's a negative exponent, it's going to be repeated
Subtract, no.
Division.
division. We still start at 1, and I'm going to divide by
5.
1, 5. 5 to the negative 2 would be 1,
Over
not
10.
over,
Divided.
divided by,
10.
nope,
5. And then another 5?
Negative.
Dang.
Oh.
right? This is how many times I'm repeatedly multiplying by 5. This is how many times I'm repeatedly dividing by 5.
Dang.
That's it. Okay? Do you understand now why 5 to the 0 is 1?
Yeah, I do know.
So if it was 5 to the negative 3 would be equals 1 divided by,
5 to the negative 3,
yeah,
that would be 1 divided by,
5 times 5 times 5.
yeah, that's what I
Right.
said, okay.
I didn't hear the first part of your question. Okay, but that's why x to the 0 is 1. Because anything raised to the 0 will give you 1. Okay, so, cubic function, right? That quadratic additive rate of change, notice the rate of change is always 1 power less. And we'll continue to look at that throughout the rest of this unit. Alright, but also, 6, 7, 8, so negative 2, negative 8, that's the first point, correct?
Yeah.
Then negative 1, then 0, 0, and then 1, 1, and 2, 1, 2, 3, 4, 5, 6, 7, 8.
Square root.
Not square root, bud. It's the same exact function we already
I
identified,
mean cube.
a cubic.
I don't know why we getting them mixed up.
Because you're not slowing down to think, you just want to spit answers out, because what we've always valued in academics is you quickly get an answer. I don't care how quick you get it, I care that you slow down, you think about it, and get it right. So don't just shout things out, slow down and think about it, okay? But notice, that is a cubic function. Didn't we look at that for the first bell ringer question?
Yes.
Has that changed? No, we looked at it as a rate of change. We looked at it graphically, and they all confirmed the same thing, right? And fundamentally, I want you to always remember, every point in that table should make the equation what?
True.
True. So check it, right? Originally, Dawson, I think you said it was quadratic, right? And so if we look at it as x squared, is negative 2 squared negative 8? Is that true? No. So is it quadratic? But if I check cubed, what's negative 2 times negative 2 times negative 2? Negative 8. What's negative 1 cubed? Negative 1. And so I want you to notice, are you just supposed to magically look at the table and know the answer?
No.
No. There are lots of ways to do this, and so I write these notes down. One, you should already have the most complicated part of it down, the rate of change. The rate of change is beautiful, and I don't ever want you to miss that. But yes, is that harder, Omar, than just graphing it? Yeah. Right? But if you graph it, do you see a cubic function right away?
Wait, oh yeah.
Yes, we definitely see a cubic right away. And then don't forget to check your answers, right? So you should have already written down, you can graph to ID the parent function when given a table? Ew, why did no one call me out on that? When given a table? That was grody. Okay, when given a table, and if you wanted to draw a quick sketch of that graph out, you can see, hey, that is a cubic function, and then also make the note to yourself, every point should make the equation what? True.
So if it has a linear rate of change, it's a quadratic
Function.
function. Alright, then.
It has a quadratic additive rate of change. It's a cubic function, meaning x to the third. Anybody want to make a prediction? What kind of function would have a cubic rate of change? X to the fourth. That's it.
What parent function that is?
X to the fourth. We'll look at it next unit. Okay.
I'm thinking about square though. Something with square. Is it something with
X to
square?
the fourth.
Yeah.
It's called a quartic.
Oh,
But-
never mind.
We'll get there in a second. All right, it doesn't look like anyone's copy. Actually, I have a handful of copies of these notes down, so I'm going to respect that. The rest of y'all, I hope you remember this because I can't make this more clear.
I wrote down cubic equals x third. Also, it is.
Q1, do you need like a pencil instead of a highlighter? You know you can just ask, right? There's these free ones over here. Gerald, you need one too?
Yeah.
Okay, when y'all walk in, grab these pencils. They're not great, but they are cheaper than buying full ones, so I have lots of them. So I have 4 more packs back there, don't just waste them. Okay? So I should probably like label this 1, 2, and 3. Those are the details we want to notice and kind of in that order. I will point this out because this is the last detail I want to emphasize. Every point makes that equation true. So what's another word that I could use to describe those points?
Equivalent.
Not equivalent. Remember, equations can be equivalent. They look different, but they're the same. But there's a really, really important mathematical word for things that make an equation or make an inequality true.
Solution?
Solutions. Every single one of those points is a solution. That's something fundamental that we need to recognize. You can never forget that what makes an equation or makes an inequality true is a solution.
Miss Skinny,
No.
I don't think I'm gonna get all this down in time. I can take a picture of it and write it down later.
No, you should have started taking notes later. I've got a video camera set up in the back so you can go watch the video if you need to take notes. So don't forget, guys, you do need to be personally responsible when we are taking notes like this, but I always have the camera set up in the back so you can get this information later if you really want it. Okay, so here's our agenda for today. We already went over the bell ringer. Hopefully we understand parent functions a little bit better and multiple ways to identify those parent functions. And again, don't forget, should one representation be one type of function and another representation another type of function? No, Mr. Kenny. Thanks, guys. Right. Notice, in the table, we saw that it was a cubic function by the rate of change. In the graph, we saw that it was what type of function? Cubic. And in the equation, what makes those points, or the points that make which equation true? X cubed, so it's cubic, right? Every representation tells the same thing. Really couple of quick notes on the unit tests and test corrections and the grading rubric and even active collaboration rubric. On your desk when you walked in, you should have each gotten this, which I emailed out to y'all. I went through each of the problems and problems that went together. I typed out notes that should help you make test corrections. I know that we can't all make it to tutoring. You do need to make it to a tutoring session or 2 to improve your understanding for the problems that you missed on the test. I need to check to see if I need to pass any more out. A handful of us, like Gerald, I don't think you ever took the test, so right now, if you have a 0, you'll have to do the retest in order to not have a 0 in the grade book, okay? But you have this to help you work through the problems before you do your retest. Does anyone remember when the retest, or when you have to complete the retest by?
March the 9th.
March the 9th. Does anyone know when that is?
Next week.
Next week. Next Wednesday. Alright?
Need a little bit more time.
When? Spring break, the end of the 9 weeks is next Friday.
Are you gonna give it to us, or you gonna have to come in?
You're gonna have to come in here. If we have a time for review to prepare for the 9 weeks exam, which I hope we do, then you could take the test on Wednesday.
Prepare for 9 weeks exam, you do too?
You have the test and all the information that you need and lots of practice problems, but
On to the next.
Shut up.
you got stuff to learn. Alright, really quickly, I wasn't loving, which I apparently made a typo here. Huh?
You said you had, I said.
Hey, Mr. King.
Yeah.
We can't be exempt from the exam.
Not from the 9 weeks exam, you can from the end of the semester
Yeah,
exam.
it ain't never been first time we like that.
Yeah. So, this is a slightly updated rubric. If you want a copy, let me know and I will print it out for you. This is what I'm working off now because I went and added clarification so that you can have a C indicating conceptual issues, a D or a P, so D missing details, P for procedural error on anywhere from 4 to 4.5 to 5. But remember, this rubric is not a grade. This rubric is saying this is how much evidence I saw of your true understanding, right? A 5.5 is what I am going to consider 100 on this test. And so that's something to keep in mind. I think I set a 3 as a 70, right? Because little or no evidence of conceptual understanding, that average of a 3 is what became a 70, and so I have that in Excel. But please understand, this is not just a grade to give you a grade. This is telling you this is how much evidence I see of your complete understanding. That is not to say that is the amount you do or don't know if you made a lower grade. That is not to say that that is the maximum that you can do. The whole reason why I'm doing test corrections and a chance for a retest is because I am firmly convinced that all of us can improve our understanding and could have done better the first time around. We just may need to change the way we're studying. Handful is already coming in, working on test corrections, and I applaud them. The rest of y'all, if you want to do test corrections at home, and then come in for a tutoring session to go over it, make sure you understand how to fix your mistakes, cool. That's why I printed out this sheet and took the time to type it out and give you notes. You'll even notice that I went in and identified different videos that can help you improve your understanding, and so just pay attention to that. What are your questions before we continue forward?
So 5P is just like, you got it right, and you try to justify it, but you just had an error.
No, so 5C would be an error in your justification, like some small part that's not like essential to what we're talking about, it's just tangential, meaning it's related to but not the main point. If you get a 5P, that actually probably means you got the wrong answer, but you got the wrong answer because it was just a small procedural error. Maybe you forgot a negative sign, or you wrote down +4, but it's very clear you accidentally subtracted 4 in the calculator or something like that.
Okay.
That's what a procedural error is. So you probably have the wrong answer, but it was just a small mistake that caused that error.
And you still marking it wrong though, right?
Okay. Are you earning a 6? No. Are you earning a 5, which is near 100?
Yeah.
Yes.
So what's a 5, like a 80?
No.
So you
If
get
a 3 is a 70 and a 5.5 average is 100, a 5 is like a 90 something.
Okay.
So you basically giving us like partial credit, like per question we get, like whatever.
I wouldn't think about it like that. What you're thinking about is a grade. What I am saying is, I see clear evidence of your understanding. You just made a small mistake. Y'all gotta change your mindset from just getting a grade and moving on. It's what evidence do I see of your understanding? That's what this is saying. And what I'm saying is, I see very clear evidence of your understanding. You just made a small procedural error, meaning the process of doing the work, you made a small mistake there. Okay? But stop trying to think of it as partial credit. I mean, you can kind of think about it like that, but again, it's the feedback of what level of understanding I see. Okay? Active collaboration rubric, I'm going to upload this onto Schoology as well. I do want to point that I made I made differences in small group versus whole class. One of the big things is I want to point out right here during whole class discussions, before I said you had to do all 3, sharing thoughts and discoveries, asking questions, and taking notes. I took that language out because I saw that some students were just going through the motions of making sure they talk, whatever. I'm not looking for you just saying something, I'm looking for a quality of thought. And so the student actively shares thoughts and discoveries, asks questions both in general and of other students' ideas, pushing for greater understanding and taking notes. That's what I'm looking for. And I will say, you don't have to do all 3 of those, but you need to be consistently doing all 3 of those in order to earn a 5. With the engaged, I still am leaving it, you have to do at least 2 of the following: actively sharing thoughts, asking questions, and taking notes. And I left it that short, but what I'm really referring to is these ideas of sharing thoughts and discoveries, asking questions in general and of other students' ideas, pushing for greater understanding, and taking notes, right? So I am basing it on all that. If you want a copy of this slightly updated rubric, let me know and I'll print one out for you. I just want you to be aware of those differences. Today, our focus is creating equations of transformed functions from tables and graphs. So if I give you a table, you need to write the equation for that transformed function. Now, we'll emphasize, before you can identify or write an equation for the transformed function, what do you have to identify? The parent function. You got to know what that is before you get started, okay? So keep that in mind. We're trying to identify the rule of a function for which a transformation is represented graphically, tabularly, or an equation, right? So if I give you a graph, a table, or an equation, you have to identify the parent function first, and then what do you have to identify in order to write the transformed equation? Got to identify the rules or the transformations. You can't write the equation until you identify the parent function and until you identify the transformations, and then you're just putting it all together. So y'all worked through this a good bit last week, right? You identify the parent functions from the equations and then the transformations. And I believe on Friday y'all took that into these tables, correct?
Correct.
And then we made the graphs?
Correct.
But we did not get to these. Okay, so this is where we're going to pick up today. I need you to hear me very clearly on this. I'm going to give you all about, I don't know, I would say 6 to 7 minutes to at least complete one, if not complete 2 of these. Whatever you don't finish during that time before we have our whole class discussion is going to be a homework assignment that is due on Friday. So let's be working efficiently to make sure we get as much done as possible. Why are you looking at me like that, Omar? Okay. So, okay. But we're going to pick up here for the sake of time. Yeah, so this, we're starting on the back. This is the Transform Practice 1. So you should already have this. We are starting on the back. This is 3A, I think is what it's labeled as. He doesn't have it. I'll come and talk to you in a second.
Wait, what is it? I don't see that.
It's on the very back of the... No. Anthony, it's what y'all were working on last Friday.
Oh.
It's what you were working on last Friday. In the top... Actually, doesn't say it. No. But it looks like this on the first page.
Okay, I got it.
This on the first page.
The book, y'all. The book.
Okay. Now, I will say this. Now, let's start with this one, because we haven't done as much with cubics. So don't forget, what is the first thing that you need to do when dealing with transformed functions? You need to do what?
Graph. Oh,
You need to what?
Identify the parent function.
Identify the parent function.
it's a cubic.
If you don't know the parent function, it's really hard to do the transformations. Then, after you identify the parent function, you need to identify the transformations, and then we're going to put it all together to get the transformed function. Alright? Keep in mind what you did on the previous set of problems. You don't just have to blankly stare at the sheet of paper. Look at the previous set of problems, see if that can give you some hints as to what to do. You got plenty of room to show work. What are your questions before I let you get started?
Oh, we turned this in.
Not today, but yes.
Either 3 or 4 being multiplied.
Yes, the only operation you don't ever have to show is that multiplication symbol. So it's understood to be multiplied out in front.
So how do you write that? So that's I know that's a vertical translation.
Okay, if you think so, call me over to confirm.
And that's a vertical.
Let's get to work. Huh?
C and D.
Okay, then you gotta do that on your own. We got 7 minutes. Let's get this problem done.